All right, hopefully you did well on the quiz in the first part of the, in between the two parts of the lesson. Students in here seem to do very well for the most part. Go and get your handout out that I gave you yesterday. We did those first three problems, kind of figuring out what the slopes of those lines were, and that's as far as we got. I want to continue with what we were talking about yesterday. And I gave you an equation, maybe something like this, y is equal to 2/5 x minus 3. And we said if we wanted to graph this equation using slope-intercept form, super easy. We said, first of all, you'd plot the y-intercept. Now, class, what is the y-intercept in this equation? -3. Because remember, slope-intercept form, y equals mx plus b. This here is my y-intercept. So remember, we'd go down, 1, 2, 3 on the y-axis, put a point there. And then from there, we would find our slope. Well, what's the slope, class? 2/5, which means if slope is rise over run, class, from this point on the y-axis, our y-intercept, we would rise we'd rise 2, and we would run 5. Which direction? Forward to the right. So 1, 2, 3, 4, 5, and we put another point there, and then we take our straight edge, which is over here now, and we would connect the dots with it, and we get our line. And we said super easy because there's no math required, and I'm a big fan of not having to do math because that means I'm getting paid for nothing. All right, and we remember this from yesterday. The problem is equations don't always look like this. They don't always come in slope-intercept form ready-made for you. Sometimes they may look kind of like this one, like a 3x plus 4y equals -16. And so you may have to get the equation into -16. You may have to get the equation into slope-intercept form. Does that make sense? The nice thing is you're good at that because all you have to do is move stuff around. For instance, for slope-intercept form, remember we said we need the y by itself, then of course the equal sign, then the x term, and then the constant term at the end. Well, if I want to get this y by itself, that means the x term's got to go. Well, that's easy enough. What do I do to move the x term over, class? Make it a -3x, so subtract from both sides. The important thing to remember is when you move it over, make sure it comes right after the equal sign because it's y equals the x term plus the constant term. So put the -3x before the -16. That's not hard math, at least. Agreed? Now the next step actually is math, I'm afraid, and that is to finish getting the y by itself, what do I have to do with the 4? Divide away from both sides, or here's another way I want you to think of it, divide it away from everything. If you divide everything by the 4, that may make your life easier, because now we can see the y by itself. I see a fraction here, and I don't care. I actually like the fraction. The only time in my life I like a fraction is slope. Otherwise, I hate fractions. And fortunately, right here, it divides evenly, class, and that's simple math. -4. So it's not a hard process to go from this to that, but it's important to get it to the slope-intercept form. Does that make sense? Then from there, it's plot the y-intercept, like we said before, down here at -4. Rise 3, run backward 4. You see the rise and run, and then draw the line, and we've got our line there. Questions on how to go from not slope-intercept form into the slope-intercept form? Does it seem fairly straightforward? Let's practice with this. On your handout, I want you to look at number 5. Number 5, we got a 5x, -2y is equal to 20. Now, I'll be honest, I'd probably graph this intercept method because I can see the intercepts like that. I mean, plug in a 0, I got a 4, plug in a 0, I got a -10. I mean, super easy. But we're not going to do that. We're going to put it in the slope-intercept form, which means getting the y by itself. So the first thing, now notice, class, it's a -2y, isn't it? I hate negatives. Because I may have to divide a -2 later, right? Strategy tip, if the y is negative, double switch. Does that make sense? Right, do you all understand that this is still slope-intercept form? Y by itself equals mx plus b. So we could do that, or we could just divide the negative later, but most people mess up dividing negatives, so I don't want to do that. Let's double switch it. What does it look like if I send the 2y over and I send the 20 over? Kendall?
5x minus 1 equals 2.
There we go, because they both just changed signs. And now, to get the y by itself, class, I have to divide everything by 2. And that ends up giving me my y by itself is equal to, well, no, actually not. Leave it as a 5 halves x. We're fine with that. And then here, class, negative 10. So if I were to graph it, which we're not going to just yet, y-intercept negative 10, rise 5, run forward 2, connect the dots. Questions on that? Look at number 7. We've got a 3x positive 2y equals negative 4. This time the y is not negative, so I don't need to double switch it. I just need to get it by itself. Maddie?
2 equals negative 3x.
Good. Move the 3x over as a negative. We'll leave the negative 4. And then? And when I divide away the 2, what's my final answer? There we go. Any questions on these first couple that we've done? Don't want to leave anyone in the dust. Everyone doing good? Feel like you're keeping up? All right. On the next one, we got a 2y positive 4x is equal to 8. And Genesis, what do I do to get it into slope-intercept form?
2y equals 8 minus 4.
Okay, careful. Remember, when we put the x, let's always put it right after the equal sign. So let's drop the negative 4x in and then leave the positive 8. Does that make sense? All right, and then? Now this time, we could actually simplify the fraction if we wanted to. What would we get? Though it wouldn't hurt, remember we said yesterday, if you see a whole number, to put it over 1, because I've had students think to themselves, oh, I rise, but there's no run. No, there is run. It's backward 1 run. So maybe leaving the 2 over 1, but it looks nicer with a negative 2. All right, questions on this? Everyone still feel like you're keeping up okay? All right, and then number 11, we've got a, this one's kind of a weird layout. We got a 3x equals 6 minus 2y. Audrey, what do you suppose we should do here to try to get the y by itself?
You add it to the other side.
Good, since it's negative, move it. I don't like negative y, so if we move it over, it becomes positive 2y. And at the same time we move it over, let's also move the
3x
to get 2y, now on this side, is equal to
negative 3x plus 6.
good, negative 3x now on that side, and we'll leave the positive 6 where it is. Everyone follow the switches. Again, that's the reason I like to teach that. After I teach, in Algebra 1, I teach them, add the 5 to both sides. Divide away the 3 from both sides. And I'm like, you know what? It's faster if we just treat it like moving it, because moving it just is a faster, more intuitive way of thinking. Finally, to finish it out here, Audrey, of course.
Divide the 2.
And what do we get for y?
Negative 3 minus x plus, plus 2, 3.
3. There we go. All right. Do you have to show that divided by 2s like we saw here? Actually, they're all divided by 2s, aren't they? That's weird. Do we have to show that? No. You can do it this way. Oh, maybe it'll help. Questions on this? All right. Do 4 through 10 the even. Do 4 through 10 the even numbered problems on the handout. Again, not graphing yet. We'll get back to it, but just making sure we can take any linear equation and get the slope-intercept form that we want. Several people already done. Show offs. I mean, good job. Thank you. You're welcome, Michael. All right, number 4. What did you get when you rewrote the equation in slope-intercept form? Michael?
Y equals x plus 1.
Good. Now, based on that, what's the y-intercept? How much will you rise and run?
1 and 1.
1 and 1. Good. Number 6. What's the equation in slope-intercept form? Abby.
I have y equals negative 1 over 1 x plus 2.
Good. What's the y-intercept?
2.
And the slope?
Negative 1 over 1.
Good. By the way, I just realized I wasn't repeating these, so I'm not sure if you could hear that on YouTube. The first equation, y equals x plus 1, or y equals 1 over 1x plus 1. We can see this y-intercept of 1, the slope of 1 over 1. On number 6, Abby said y equals negative 1 over 1x plus 2, where you can see the y-intercept of positive 2, and the slope of negative 1 over 1, rise 1, run backward 1. Number 8, what did you get for your equation in slope-intercept form, Brandon?
I have y equals negative 2/3 x, positive 4/3.
And this one's would be a bit of a pain to graph, because you'd have to find your y-intercept at
4/3.
4/3, 1 and 1/3, and then you'd have to rise,
Negative 2/3.
right, so we'll rise
2.
2 and then run backward 3, right, to the left 3. Y equals negative 2/3 x plus 4/3. And then number 10, Genesis, what did you get for your equation?
Y equals 2x minus 4.
Good, where we can see that the y-intercept is
4, negative 4.
negative 4, and then the slope is
2.
or 2 over 1, where we rise 2, run 1. So y equals 2x minus 4, y-intercept negative 4, rise 2, run forward 1. Numbers 13, 15, 17, go get some graph paper out. I want you to put them in slope-intercept form and then actually graph them. So 13, 15, 17. Now that I'm confident by the way, how many went 4 for 4? You got all of them right. 4 for 4. Okay, excellent. Now that I'm confident we're good with this, put them in slope-intercept form and graph. I'm going to do the whole process now on 13, 15, and 17. Set up your graph grid for practice sake. Make sure you set it up the way you would for a quiz or test, making sure you put the arrowheads, the X and Y labels, the increments, all those things. And I would do all 3 graph lines. If you have different colors, use those. If you have to, maybe dotted line, dashed line, solid line, something like that. Some way where you can tell the difference. The colors are nice. God gave us color to make it a little more enjoyable. Yes. And since Brandon wants to be godly, he has different colors of pens. Once you finish, check your work against the board, see how you did. Good to go. Sorry. Did you figure out what you did? What'd you do?
I did it backwards.
You ran and then rose instead of rise and then run? Okay. Mistake reciprocal of my slope. I did backwards. Mr. McDonald and his, what was that word? Indolent? That's a great word. I think that's actually been one of your vocab words, right? Yeah. All right, any questions on 13, 15, and 17? Any questions on the algebra work? Any questions on the graph itself? Questions at all on this? The only one on here that's really weird is the next odd problem, and it's number 19. Look at it for a minute. We've got y minus 4 equals 0. There appears to be something missing, doesn't there? What appears to be missing here, class?
X.
The x. If we wanted to say there was an x, we would have to say it was a 0x. Does that make sense? Because there are no x's, there's 0 x's. But then if we were to move the 4 over as a positive, we could say y equals 0x plus 4. Well, what's my y-intercept, class? 4. And my slope is 0. 0 over 1, but just 0. And 0 slope looks like what? Side to side, horizontal line, right? So that would actually be really easy. And if you think about it, if you think of just ignoring the x factor for just a moment, simply saying y equals 4, think about every point on this horizontal line. Y equals 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, 4. You get the idea? Negative 1, 4, negative 2, 4, negative 3, 4. All the y values are 4. So the equation y equals 4 must be a line for which every y value or every ordinate is a 4. What do you suppose a line x equals negative 2 might look like? Pull all the points that have an x value of negative 2, like negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 3, negative 2, 4, negative, you get the idea? It'd be a perfectly vertical line through the x at negative 2. This is a perfectly horizontal line through the y at 4. But anyway, you won't see that very often, but thought I'd point that out to you. Your homework this evening is to do 2 graph grids. 2 graph grids. Each graph is going to have 3 lines on it. Okay, each graph will have 3 lines on it. You're going to finish the handout, which is numbers 12 through 20 even. Handout, 12 through 20 even, and 21. 12 through 20 even, and 21. So 12, 14, 16 go on one grid, and then 18, 20, 21 go on the next grid. So 2 grids is what I should be looking at. Each grid should have 3 lines. Real graph, 12 through 20 even, and 21. All right, have a wonderful rest of your day, a wonderful weekend, and you are dismissed.